What I want to look at here are the ways in which two lines, can intersect each other. And we're going to examine this idea looking at three separate cases. So the first case, I'm given two equations here, 2x minus 1, and I have y equals negative x plus 2. So if I were to graph these, first of all, they're in perfect form. They're in y equals mx plus b form, so it's easy to graph them. If I were to graph the first one, I'm going to have a y-intercept of negative 1. So there's my first point right here. And based on my slope, that's 2 over 1. So I go up 2 and across 1. There's my next point. So if I connect these points with a straight line, it looks something like this. And it goes infinite in both directions. My second equation has a y-intercept of 2. Y-intercept of 2 over here. And the slope is negative 1, so down 1 and across 1. So it's that same point. And if I draw a line through it, it looks like that. Again, I apologize for my unsteady hand, but I think you get the picture. So these two lines, they intersect at one point. And what that point is, if we zoom in, we go across 1 and we go up 2. The point is 1, 2. So the second set of equations, let's take a look here. They are not in y equals mx plus b form. And I'm going to put them into that form because I want to be able to graph them easily. So I'm just going to rewrite them quickly. And I would recommend that you try to do this by yourself to see why this is true. Make sure you write them so that they're in recognizable form. Y equals mx plus b, negative 2 over 3 plus 4. So it goes from semi-standard form to y equals mx plus b form. So my first equation has a y-intercept of 2. And the slope is down 2 across 3, so here's my second point. And if I connect them with a straight line, it looks something like this. My second line has a y-intercept of 4, so it's going to be up here. Down 2 across 3 over here. If I connect them with a straight line, it looks something like this. And that's a little bit off, so let me just see if I can move this a little bit. Just lift it up there. There we go. Anyway, I did my best. There are the points. And again, I know they're not perfectly straight lines, but you get the picture. So in this case, the lines look like they are parallel. Okay, it looks like they don't touch. Don't find a point of intersection there. Finally, I have an equation here, two equations. One of them is in good form, that's this one here, and the other one I'm going to rearrange. I'm going to put it into y equals mx plus b form. And again, convince yourself that this is true by working on it by yourself. And notice that I get y equals 5x plus 1, which is identical to this equation here. So what does that look like? It's 1 on the y-axis and a slope of 5 over 1. So up 5 across 1, there is my second point right here. So when I graph this line, it's a very steep line. I won't try to graph it perfectly, but it looks something like that. And it's supposed to pass through this point here. Let me try that one more time. So the line goes from here, up here, and then it keeps on going down. It's even worse. Anyway, you get the idea. It's supposed to be a straight line through these 2 points, infinite in direction. The thing is, it's the same line. The first and second equation are identical. So let's analyze these results and see what they mean. And by filling out this table here. So the slopes of the lines. Well, for the first set of equations, the slope of the first line is 2. The slope of the second is negative 1. Again, I'm just reading these values here. The y-intercepts are negative 1 and 2. I'm reading these values here. and the number of solutions is 1. And I'm reading that from the graph itself. I notice that my graph has one solution. Solution meaning point of intersection. Now over here, L1, the slope of the first one, and I have to go to the modified one, is 2 over 3. So the slopes of both these lines are actually negative 2 over 3, sorry. The intercepts, the first one is 2, the second one is 4, and they have no solution. Or better yet, I just should put 0 solutions. And for the last one, well, we saw that the slopes were the same, and the y-intercepts were the same as well. And the solutions, well, if you have a line lying on top of another line on every single point, we say it has infinitely many solutions, or just write the infinity sign. So those are the 3 ways in which lines can interact with each other. Either they intersect at one point, or at no points, or at infinitely many points. And down here is just a summary of all these facts and some of the consequences of them.